Bismillahirrahmanirrahim. Today I wanted to elaborate on radical functions. Previously we had talked about graphing of radical functions, and we had started out building our knowledge based on the parent radical function, which was y is equal to square root of x. And conveniently, the parent radical function kind of looked like a radical symbol like this. I had suggested that the general equation for a radical function looks like this. F of x is equal to a times the square root of x minus vx plus vy, like this. And if you recall, the starting point of the radical function, we had affectionately called it the pseudo-vertex, a terminology that we derived from the parabolas. The pseudo-vertex, pseudo means false or fake, because it's not like a true vertex. The pseudo-vertex is the vx and the vy. And the ordered pair that belongs to the pseudo-vertex we had derived from this general equation, and those would be the numbers that are located there. Also, if you recall, this a over here was very important. That kind of determined how tall, how fat or skinny the graph was, and whether or not it was a reflection or the flip or the mirror image of the parent function. Now, knowing that, we could easily graph a function like this. F of x is equal to 4 times the square root of x minus 2 minus 1. Now, in order to graph this, you had to recognize that the 4 is the a, the 2 here, not the negative 2, the 2 here is the vx, and this negative 1 is the vy. So the first thing that we had to be able to do is recognize a radical function when we see it. And more than that, we had to recognize the components of the radical function, this multiplier a over here, and the vx and the vy. And if we were to graph this, the first thing that I would do is I would find the ordered pair that corresponds to the vertex. In this case, it's going to be 2 and negative 1, because this has to be a plus sign like this, and then it would correspond identically to the vy. So in this case, see, the vertex is 2, negative 1, or I should say the pseudo-vertex. That's 1, 2, and negative 1 right here. And we can label the pseudo-vertex as 2, negative 1. And then you observe that this 4, that's a positive number. So this graph will open up like this. It won't be a reflection like this, correct? So this graph will open up. In other words, it will kind of look like this. Now, in order to graph then, we have to get at least a couple more points, right? So we do what we do best. We make tables. So here's x, and this is f of x, or the y value. Now, you kind of know what it's going to look like this, right? So you can just substitute any numbers here, 3, 4, 5, 6, whatever you want, and to get a corresponding y value or the f of x value, and then you would have some points. So we can substitute a 3 in place of x. So what's the value of f of x when x is 3? So let's do that. So f of 3, that is the value of the function x is 3, is 4 times the square root of 3 minus 2 minus 1. So this will simplify to 4 times square root of 1 minus 1. Square root of 1 is 1 last time I checked, so 4 minus 1 is 3. So when x is 3, f of x is also 3. Now we can substitute 4 for x, or 5 for x, or 6 for x, or 7 for x, or any x, right? But if you substitute 4 for x, you get f of 4 is equal to 4 times the square root of 4 minus 2 minus 1. This is 4 times 4 minus 2 is 2, square root of 2 minus 1. This is not a nice number. You can do this on a calculator and get an answer, and that's okay too. And this, I believe, comes out to about 4.66. So if you did that, you could say, well, when x is 4, this is about 4.66 over here. So let's plot this. When x is 3, f of x is 3. It's 1, 2, 3 right here. And when x is 4, it's 4.66. So it's 4 over here and something like that. And that would be sufficient. And there you have your graph. Now, if you wanted a nice, neat number, you have to be a little bit creative. You have to look at f of x. So f of x is equal to 4 times the square root of x minus 2 minus 1. And you have to say, okay, what can I put in there to get like a perfect square? Well, the perfect squares are 4, 9, 16, 25, right? So how do I get like a 4 over here? Well, if I put 6 over there, 6 minus 2 is a 4, right? So that's what I would do. So 4 times square root of 6 minus 2 minus 1. So here, this will work out, see? So 4 times square root of 6 minus 2 is 4 minus 1. The square root of 4 is 2, so that's 4 times 2 minus 1. And 4 times 2 is 8 minus 1, and that is 7. See, this works out quite well. So when it is 6, it turns up to be like over here, actually. See, so you can see it's kind of like nice to be able to do that. Now you have this graph kind of going like this. That's a more proper graph, okay? But you get the idea, right? So in trying to find extra points, you can substitute any points. But if you use a little bit of creativity to make sure that the radicand becomes a nice and neat perfect square, then it helps out a little bit. But that just comes with practice. So what we did so far is that I suggested to you that y is equal to square root of x is the parent radical function, and I had suggested to you that f of x equals a times the square root of x minus vx plus vy. This is the general equation of a radical function, and I've done an example of how you graph a function that's given in this form. Now what I like to do is, how do you find the equation of the function if you're given a graph like this? For example, if you're told that this is a radical function, and what is the equation of this radical function? Well, how do you go about doing that? Well, the concept is this. See, if you wanted to write the function, you would really have to only know two things. First, you would have to know what the vertex is, because then you can fill out the vx and the vy. And secondly, you would have to know what the a is. So for any radical function, if you knew what the vertex was, and if you know what this a is, then you could write the function, the equation for the function, right? So if we wanted to write the equation of this function that you see before you, we would have to first find the vertex, and secondly, we would have to find the a. So let's first find the vertex. Oh, here it is. So the vertex. So that was easy enough. So the vertex, or the pseudo-vertex, is -4 and -2. That was pretty easy. So now we can write our working function, the working equation. So we can say y is equal to a square root of x minus vx. In this case, vx is -4 plus vy, which is -2. Now, do yourself a favor. Be very careful with these negatives, okay? Don't do silly mistakes like x minus 4 or something like that. It's not x minus 4. It's x minus -4, okay? So you can simplify this as y is equal to a times the square root of x plus 4 minus 2. Okay, now that's pretty good, but we don't know what the a is, right? Now, how do you go about finding the a? What you do is you find another point on the graph and substitute that ordered pair in place of x and y over here, and then you solve for a. Doesn't matter which ordered pair you pick. So you pick any ordered pair and substitute in place of x and y, and then solve for a. And that's what we're going to do. Well, what ordered pair I'm going to pick? Well, I'm going to pick something that's easy, okay? So, oh, this one looks good because it's like right there, right? So what ordered pair is that? Well, x is 0 and y is 2. So if we substitute this ordered pair in this equation here, then we can solve for a. Let's do it. Okay, now we have 0 equals a times the square root of 2 plus 4 minus 2, right? Wrong. No. X is 0, y is 2, not the other way around. So what I did was I put y as 0 and x is 2. Just be careful. So let's do it again, and this time we'll try to do it correctly. So we have y is 2 is equal to, a is what we're trying to solve for, square root of x, which is 0, plus 4 minus 2. All right, so let's simplify. So 2 is equal to a times the square root of 0 plus 4 is 4 minus 2. And then we have 2 is equal to square root of 4 is 2. So this is 2a minus 2. And then I add 2 to both sides like this. I have 4 is equal to 2a. And I divide both sides by 2 like this. From here, I get a is equal to 2. Ta-da! We have it. So now we know what a is. And we can write the entire function like this. Y is equal to 2 times the square root of x plus 4 minus 2. And there we have it. And this is the equation of this function. If you wanted to write this, you could write it over here. So y is equal to 2 times the square root of x plus 4 minus 2. So what I did today is I gave an example of a radical function and we graphed it. And then we looked at a graph and derived the equation for the radical function. The way you do that is first you find the vertex and then you try to find the value of the multiplier using any point other than the vertex, of course, in finding that a. I hope you enjoyed. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.